persons live in a conical tent whose slant height is 19 centimeter. If each person require 22 centimeter square of the floor area, then find the height of the tent. So this is the question. So in this question, let's first identify what is given. Okay, if we identify the given data, then that is enough for us to identify whatever is the question. Okay, we are given a conical tent here. So first let's imagine a rough figure. Let's have a conical figure. Right. Okay, we are told that the slant height of the cone is 19 centimeter. So this is nothing but the slant height from this point till here. This is nothing but 19 centimeter. This is called as the slant height. You can denote it as L, small l. Okay. If each person require 22 centimeter square of the floor area. Okay, so in this conical tent, okay, which will be the floor area? Will this be the floor? No, it becomes the top. So this becomes the floor area. Okay, each person require 22 centimeter square of the area. So 4 persons are there. Okay, so can you see this shaded region? This is nothing but the floor or the base. Okay, so this base area is mentioned as 4 into 22 centimeters square. How we are identifying this? Very simple. In this conical tent, we are having 4 persons to live in. Each person require 22 centimeters square of the area. So if 4 of them are going to live in this conical tent, 4 into 22 will be nothing but the base area. Okay. So this is the given data. With this given data, we are going to identify the height of the tent. Height from this top to this center. This is nothing but the height. Okay. So again, this is like a right angled triangle. Yes or no? So the side opposite to 90 degree. This becomes hypotenuse, which is 19 centimeter. This is the height of the right angle triangle. This is the radius of this that is circular cone. And at the same time, this becomes the base of this right angle triangle. Do we know this radius of this conical figure? We don't know the radius. Okay. So first, let us identify the radius of this conical figure. And then let's see how we are going to identify the height of the cone. Okay. So to identify the radius of this cone, that is the circular base, okay, we are given the base area of the cone. Okay, so base area is equal to 22 into 4 centimeters square. Okay, what is the base of the cone actually? The base of the cone is always a circle. Yes or no? So base area in the sense the area of this circle is mentioned here. See, this is a 3D image. So that is why it is looking like this. Okay, so base of a cone is always a circle. Okay, so the given area, it is nothing but the area of the circle. Okay, so pi r square is given as 88 centimeter square. Okay, so r square, that is pi, we will be usually taking it as 22 by 7. Take 22 by 7 to that side, it goes in the reciprocal form as 7 by 22. So 22 into 4 becomes 88. So r square is equal to 4 into 7, 28 centimeter square. Need not identify r from this. Okay, let's have r square as it is. Okay, now what is the question actually? We need to identify the height of the conical tent. Okay, so this is the right angle triangle. This is the height of the cone. This is nothing but the slant height, which is 19 centimeter. This is the radius, which is 28 centimeter square. R square we are having. Okay. Now children, this is a right angle triangle. By applying the Pythagoras theorem, okay, can we identify H? Yes, of course we can identify. So this H is nothing but square root of L square minus R square. Why? Because by applying the Pythagoras theorem, okay, the hypotenuse square will be equal to the sum of the squares of other two sides. So L square minus R square will be equal to H square. So L square minus R square with the square root. This is nothing but H. So this concept only we are using here. Okay. So this is square root of. What is L square? 19 square minus R square. Don't square this. R square, it is directly 28. Okay. Please don't write 28 square. R square, it is directly 28. Okay. So now 19 square, that is 361 minus 28. Now 361 minus 28 will be 333. So this is square root of 333. So the height of this cone, it is square root of 333 units. Okay. Let's find out square root of 333. It is an imperfect square number. Okay. We are going to identify the square root for the same. Let's see how we are doing. For identifying the square root, we are having two basic methods. One is by using the prime factorization and the other one is by using the long division method. Since this is an imperfect square number, it is a good practice to use the long division method. So for that, let's have a long division. Place the numbers within the long division symbol. It is 333. Okay. This number is not having a decimal point. So from the rightmost end, pair the numbers to the left. 3 and 3, two numbers, it becomes a pair. This is a single digit, it's not having a pair, leave it as it is. Since this is an imperfect square number, definitely you will not get the accurate square root value. So let's find at least up to one decimal place. So for that, we are including a pair of 0 which are paired from left to right. Okay. So at the decimal point, if you notice, the arrow marks are pointing to the opposite directions. This is how the pairing should be inside the long division. Okay. So now this is the first digit. Look at the digit. This is 3. So identify the perfect square number which is less than or equal to 3. 1 ones are 1, 2 twos are, it becomes 4. Okay. So which is greater than 3. So the perfect square number which is exactly less than or equal to 3 is 1. So 1 into 1, 1. Few of them might write 1 into 3, 3. That will be wrong. Whatever number you write here, the same number should be written in the quotient part also. Okay. Now as like that of the usual division, subtract. 3 minus 1, 2. Bring down the next pair of digits down. What is the next pair of digits? It's 33. Bring it down. Then whatever is the quotient at that time, what is the quotient there? 1. Double the quotient. 1 into 2, 2 or 1 plus 1, 2 and have a space here. Okay. In this space we are going to fill in a digit. Okay. The same digit we are going to place it here also. That is, this is by using the trial and error method only. That is, check out for each and every number, okay, so that you get a number which is less than or equal to 233. That is 21 into 1, 21. 22 into 2, 44. 23 into 3. Like that, check out for each and every possibility. If you check like that, for 28 into 8, you get it. 8 8s are 64. 8 2s are 16, 16 plus 6, 224. Right? Subtract now. 13 minus 4, 9. Now bring down the next pair of digits down. What is the next pair? 0. Bring it down. 2 zeros. Okay. Now double the quotient. What is the quotient at this time? 18 completely. 18 into 2, 36 or 18 plus 18, 36. So with this the integral part is over. Followed by this, you have the decimal point, and now we are going to have the decimal places. Okay, so now let's identify up to one decimal place, that is enough. Okay, so if you are going to identify the number here, again we are going to use the trial and error method. Check out for each and every possibility. 361 into 1, 362 into 2, like that. Check out for each and every possibility. You get it for 362 into 2. What is that? 2 2s are 4, 2 6 are 12, 2 3s are 6 and 7. Need not subtract, leave it as it is, don't waste your time. 18.2. This is nothing but the approximate value of the height of this circular cone. 333, which is equal to 18.2. That's it. Okay. Hope you all understood. Thank you.